Most people know that a shepherd's job is to control a flock of sheep, keeping them on track and guiding them where they need to go. But did you know that there are moons in space which also act like shepherds? There are a couple of things we need to know before we can understand how shepherd moons work. Thanks to Newton and Kepler, we know how satellites move in orbits around planets because of a combination between the force of gravity and forward momentum. This means that a satellite closer to the planet must have a greater forward momentum to stay in orbit. In other words, the greater the distance between the satellite and planet, the slower the orbit. If a satellite were to speed up, it may leave its orbit and be cast into space. If a satellite were to slow down, it will drop out of its orbit and may impact the planet or be torn up in an atmosphere. A ring system orbiting a planet is made up of many small satellite particles. These are the shepherd moon's sheep. Shepherd moons help prevent the particles from straying from their orbit. If a particle is accelerated and drifts outside its orbit, it may start to overtake a shepherd moon. As it passes, the moon's gravity will start to act opposingly to the forward momentum and slow down the satellite where it will return to its original orbit. As a particle slows down and drops out of its orbit, a shepherd moon may overtake it. With the moon's gravity working in the same direction of the forward momentum, this will accelerate the particle where it returns to its original orbit. While other phenomena such as orbital resonance also play a role in the formation and continuance of ring systems, shepherd moons are one part of the answer to the question, why do planets have rings? An example of these kinds of moons exists on Saturn, where the moons Pandora and Prometheus act as shepherds for the F ring located about 140,000 kilometers from Saturn.